Let's start with our first example. We have the absolute value of 3x plus 2 over 4 equals the absolute value of 5 minus 3x over 6. So the first thing to do here is to notice that the absolute value for the first one, the 3x plus 2 over 4, looks something like this. So there's a negative version. The negative version is this one right here. And the positive version is this one right here. Because think about it. Let's pick a number less than negative 2/3. Let's say negative 1. What happens when I plug in x equals negative 1 inside the absolute value? So ignoring the absolute values. Well, I have 3 times negative 1 plus 2 over 3. That's negative 1/3. Okay. So I get a negative value there. But we know that the absolute value will always give us greater than or equal to. So that means we have to multiply this by a negative. If x is less than negative 2/3. Let's pick a number that's greater than 2/3. Let's say 0. If I plug in x equals 0 here, I get 2/3. So it's positive. That means I can remove the absolute values. Okay, so in other words, the absolute value of 3x plus 2 over 3 is going to be positive if x is greater than or equal to 2/3 and negative if it's less than 2/3. So that's all it comes down to. Determining where is it positive, where is it negative. Okay, so now let's begin the problem again. So it's always good to set the inside equal to 0. So in other words, 3x plus 2 over 4 equals 0. And that one we said x is negative 2/3. And then the 5 minus 3x over 6 equals to 0. And that is x equals 5/3. Okay, so that's step 1. Okay, the second step is to make a number line, because this organizes us very well. So we have negative 2/3 and 5/3. And now there's going to be 3 cases. 1, 2, 3. So x less than negative 2/3, x between negative 2/3 and 5/3, and x bigger than 5/3. Okay. So first case, x less than negative 2/3 makes this one negative. So that means we have to multiply by a negative. And if x is less than negative 2/3, 5 minus 3x over 6 is positive. So you can plug in, let's say, negative 1, and you'll get 8 over 6. So that's positive. So then you just solve this. You have negative 3x minus 2 over 4 is 5 minus 3x over 6. Cross multiply. Okay, so let's see. Add 12x. Add 12. So I think that's negative 5 and 1/3. And okay, so you get a nice answer. At this point, you want to make sure it's less than the condition that you're in. The condition was x less than negative 2/3. So is negative 5 and 1/3 less than negative 2/3? Yes. So we keep that answer. Okay. So that's the first case. The second case, we have to be between negative 2/3 and 5/3. So we have 3x, the absolute value of 3x plus 2 over 4 equals the absolute value of 5 minus 3x over 6. So let's pick a number between this range. Let's say 0. So if I pick x equals 0, okay, this is positive and this is positive. Okay, so they're both positive in this range, so we could just remove the absolute values. We're going to cross multiply. Add 12x, subtract 12. So we get x is 4 over 15. Now we have to double check, is 4 over 15 in this interval? Okay, the answer is yes, it is. So we keep it. If it's not in that interval, we throw it out. Now we have one more case. Okay, so we did the first one and second one. So the third one is when x is bigger than 5/3. So again, we have 3x plus 2 over 4 equals the absolute value of 5 minus 3x over 6. For this one, you want to pick a number that's bigger than 5/3, so let's say 2. If I plug in x equals 2, this is positive. Plug in x equals 2, the inside is negative. Okay, so remember, we're just plugging in the inside. We're not using the absolute value. Okay, so when it's positive, we could just remove the absolute values. When it's negative, we have to throw in a negative. So, let's see. So we're going to distribute the negative. And then cross multiply. Okay, so we get 6x equals negative 32, so x equals negative 5 and 1/3. Notice this was a previous answer, but negative 5 and 1/3 is not bigger than 5/3. So we're going to disregard this solution for this case, but we're going to keep it for the first case, because this one it works for this case. So for the third case, because negative 5 and 1/3 was not in that interval, we're going to disregard it for that case. So for case 3, there's no solution. Okay, to summarize, there's only two solutions. There's 4/15 and negative 5 and 1/3. Okay, let's look at another example. So this one will involve one absolute value. We have the absolute value 3x plus 4 equals 2 minus 5x. Okay, so again, here we have to look at the two cases. You always want to set the inside equal to 0, so you get x equals negative 4/3. So if I pick a number, let's say the left is negative 4/3, negative 2, what happens to this one? Well, it's negative. And then pick a number to the right of negative 4/3, say 0, it's positive. Okay, so there's going to be two cases here. The first case being less than negative 4/3, The second case being bigger than or equal to negative 4/3. So for the first case, if x is less than negative 4/3, because the inside is negative, I need to multiply by negative again to make it positive. So I have negative 3x minus 4 equals 2 minus 5x. We'll add 5x, we get 2x, add 4, we get 6, so we get x equals 3. Now ask yourself, is x equals 3 in this interval? Is 3 less than negative 4/3? The answer is no, so we don't include it. Okay, so there's no solution for the first case. Now for the second case, we're looking at x greater than or equal to negative 4/3. And for that, the 3x plus 4 is positive, so we're going to remove the absolute values. Okay, then we'll just solve it. We add 8x. We add 5x. We get 8x equals negative 2. So x equals negative 1/4. Now let's see. Is negative 1/4 greater than or equal to negative 4/3? The answer is yes. So we include it. So the only answer to this one is negative 1/4. All right, let's look at one more example. And for this example, it's going to be a little tricky because we want to find a condition. Okay, so it says, for what values of the variable is the equation true? Write solution in interval notation. I have the absolute value of ax plus b equals b minus ax. Okay, so think of this as, what condition makes this equation true? Well, we know that the absolute value is always greater than or equal to 0. It's never negative. So to start off, we know that this is absolutely true, so b minus ax must also be greater than or equal to 0, since they're equal. If b minus ax is negative, we'll get ax plus b being negative. And that's wrong. So the condition for this to work is that b minus ax has to be greater than or equal to 0. And so b is greater than or equal to ax, so x has to be less than or equal to b over a. So if we have a number line, here's b over a, you have to be greater than or less than or equal to that. So it's everything to the left. So in interval notation, we have negative infinity up to b over a. And that's our answer.